Hello everyone. In the last lecture, we have discussed question number 2 and question number 3 from the Group B section, electric drives for the question paper that we had received in the year 2024. So now we'll discuss the question number 4, that is why VVVF method of speed control of a three-phase induction motor is preferable to the frequency control method. That means why a VVVF method is used instead of frequency control method. So there are certain drawbacks of simple frequency control, that is torque is proportional to V square by F square into sleep. So if voltage is not adjusted with frequency, then flux will change drastically. Now, if low frequency is present with constant voltage, then it will lead to high flux, ultimately core saturation and heating. If high frequency is present with constant voltage, that will lead to low flux and reduced torque. So these are the few drawbacks of simple control method. Now, what is the principle of VVVF? To maintain constant V by F ratio over base speed to keep gap flux constant. This is the main principle of VVVF principle. So if for speed more than the base speed, that is f of the base speed, then flux is reduced due to flux field weakening in order to get constant power operation. So what are the advantages? It will provide constant torque over a wide speed range, better efficiency due to reduced core and copper losses. It will avoid saturation and overheating at low frequencies. Speed control will be smooth and acceleration and deceleration will be also smooth. It will allow regenerative braking. Where can we find such kind of control method? Is found is applications in electric trains, conveyors, HVAC system, industrial fans and pumps. The next question is, what do you mean by group, individual and multi-motor drives? It is a very important question. So first we will discuss about group drive. So when several machines are organized or connected to a single shaft and all the machines are driven by a single large motor, then that system is known as a group drive. So we are having a single shaft to which many several machines are connected, and all those machines are being controlled by a single large motor. If the system is such, then we call it as a group drive. It is also known as line shaft drive. Why? Because large size motors drives a common shaft, so they are also known as line shaft drive. So to the common shaft, number of small machines are connected by the help of multi-stepped pulleys. This is the figure of a group drive. So this is the main motor and this is the common shaft to which other three motors are connected. So this single large main motor is driving all other three motors which are connected to the same common shaft. So what are the advantages of the group drive? So as a group drive uses large size single motor, so there will be a certain amount of cost reduction and it has low maintenance cost. So in case of group drive, if any condition there is an overload condition occurring for main motor will be very less. So when main motor operates near rated capacity, then power factor and efficiency of the group drive will be improved. Now along with that, the disadvantages are, if there is a fault in the main motor, then all other small machines will also be stopped. It is not like that if the main motor is facing any fault, then the work will be done by other motors. It is not so, because they all are connected to a single shaft. So if the main motor is not working properly, then other machines will also come to a halt. In case of a group drive, the small machines have to be installed at places which is convenient for shafting. Next disadvantage, the speed control of individual small machine is not possible in case of a group drive. High amount of power is wasted in power transmissions because they are connected through pulley. Future expansion is not possible in group drive. So when a quite number of machines are required to be operated, then main motor operates with a very less capacity. So its power factor and efficiency will be poor. Layout of drive is fixed and it cannot be changed. So the structure becomes bulky. Noise is produced by group drives is very high. Applications of group drives, we can find it in food grinding mills, paper mills, textile mills, grain processing industries, workshops, and many other places. Next question part was individual drive. So when an individual machine is fitted with its own electric motor, then electric drive is known as individual electric drive. That means each individual machine has its own separate electric motor. So in that case, it is known as individual electric drive. So in case of individual electric drive, each operator has complete control on his machine. So this is the block diagram of an individual drive. Now, advantages of individual drive. It is possible to control the speed of individual machine easily. Then they produce less noise. Future expansion is possible. They The layout of it has a very good appearance, and it is flexible as you can change the structure. Means expansion is possible. In case of individual drive, if one machine faces fault, that does not cause any problem to the other machines. Individual drive is economical in long term, and in case of these drives, each machine operates near to the rated capacity, so power factor and efficiency are better. Disadvantages of individual drive: initial cost is high, power loss in transmission system equipment such as gears, pulleys, etc. Applications are in drill machines, lathe machines. Now, multi-motor drive, a mechanism in which separate motors are used for operating different parts of the machine, is known as multi-motor electric drive. If various different number of separate motors are used for operating different parts of the same machine, that means you are having a single machine, but its different parts are being operated by different motors, then we call it a multi-motor electric drive. This is the block diagram for multi-motor electric drive. What are the advantages? This multi-motor drives will provide better control of process. So with the help of multi-motor drives, a complicated process can be easily automated. In this case, each machine is driven by a separate motor, so it is not necessary that all the machine need to be started at the same time or stopped at the same time. No, it is not needed, as they are separate, so they can be individually started and individually stopped whenever it is required. It does not have bells or line shape, so it reduces the power loss and the risk of accidents. This layout of multi-motor drive is flexible for installation of different machines. Now, what are the disadvantages of multi-motor drives? Multi-motor drives involve high initial cost. Maintenance of one motor causes disturbance to the entire process. What are the applications? Applications are in hoist, lifts, cranes, long travel motion applications, cross travel motion applications. So this was all about two questions, question number 4 and question number 5 from Group B. So we will discuss the other questions in the another lecture. Thank you so much.